Welcome, everybody. Welcome, welcome, welcome. So, here we are. Hopefully you're on. Got 2 viewers. It's good stuff. It's good stuff. I'm going to get the chat going on in a second. Sorry for the delay. The thing that I was using for the other class, Doceri, it's kind of this application from my iPad. It allows me to kind of do a virtual whiteboard. So the background would be me writing on the whiteboard. It was not very clean, meaning that it was not, it didn't stream well. Let's put it that way. So I would write and I would do a problem, and then it would cut out like halfway through that problem. So that was not beneficial at all, right? So hopefully you're able to get in, and we can get to the YouTube stream in a second, so we can talk about it. Hey, what's going on? So hopefully, let's see. Okay. I want to make sure that we're on. So remember, you're going to log in. You can ask me a couple of questions about, your interim that's coming up. I'll hopefully answer those questions to the best of my ability, and then you can get off. You don't have to stay on for the full time till 4 o'clock, because I am going to go until about 4 o'clock. A little bit before though, because I do want to make sure that the dog doesn't bark the entire time that we're on. So what questions can I help answer for you? And hopefully I'll be able to do Desmos so you can kind of see the background here and we can work out some problems. But Desmos doesn't have to just be the transformation stuff. It can be, I can do some of the exponent stuff, and I can certainly do some of the other problems as well. So hopefully you can hear me, number one, and hopefully you can see the other things that I'm talking about as well. All right, I do want to make sure I got this link going on too. Sure. Okay. Very cool. So, for the review, so let's give it a couple of seconds to make sure everyone else gets in, and then if no one gets in, I can give you a couple of review questions for the interim. That looks weird. Can you see do you see all that stuff going on, this like weird mirror image type thing, or do you just see me and this weird screen? I don't know what you say. I don't know what you see. I just want to make sure it doesn't look terribly terrible. I think it looks terrible. So, copy. Yes, what? Does it look okay, or do you see like 75 me's and like this weird kind of mirror thing? Just be more specific for me. Oh, that's not good. All right, give me a second. Lizzie, you're not supposed to be on. Sophie. All right, let me see if I can get that right. Let's try that. All right. Oh, yeah. I do see that too. That's not good at all. All right, how's that? Is that better? Is that better? Is that like better? Can you see like not 75 me's now? Just want to make sure. I just want to make sure. because that's not good at all. Oh my gosh. Ah, it's better. Okay, good. That's good because that was really bad. Okay, cool. All right, so I mean, you could stay on if you really wanted to. Like, that's fine. But you know, whatever. No, go back. Okay. Okay. But I want to make sure I get I need to get this on here too. Okay, so let's screen capture. Let's smart selection. No. No. No, remove. I need help with 58. I don't know if that's what that's referencing. I don't think I know what that's referencing. That's source. Smart selection. All right, there we go. I'm going to get away from this. Apologize for you. Blah. No, what is that? What is that? Go away. Not sure what that middle thing is. What is that? What is this? Get out of here. What is this? Remove? It's better. I don't know what the 58 reference is. Can you be a little bit more specific? Is that number 58 on the study guide? I just want to make sure that I got this correctly for you. And I am trying to do so. A couple of things that happened here that were not part of how this was supposed to be captured. So a couple things. Number one, there we go. The process that I was using earlier to I wonder why that's not working this time. So this worked last time, but it's not working this time. So I have to get rid of this again. So I was using Doceri, and that didn't work. And now I'm not able to get the chat up here as I want to. So that's gonna be a little bit of a pain as well. Because you see me moving a ton of stuff around, and that's not at all what I need. So what questions do you have that I can kind of help you with a little bit here? Oh boy. I'm just gonna leave it on here. See how that goes. Okay. Ooh, 9 viewers. All right. That's good. Oh, it's me again. There's a million me's again. Nothing to see here. We popped out. Okay, maybe that'll work. Maybe that will work. Let's go. There we go. Yay! Okay. So, what do we got? What can I help you with? So let's go with a couple of things. So let's talk about oh, I don't know. Let's talk about some transformations and stuff, right? Let's do that. So let's see. I cooked up a couple of things over here. Not really cooked it, you know, because that would be weird. But let's talk about some transformations. So let's say that I had a point, and that point was at -4, 6. Okay, hopefully you can see that pretty well. So if I had a point at -4, 6, okay, and I want to translate that point, I could give you a couple different things. One thing that you might see is I might go x plus 7, comma, y minus 4. Okay, now what that means is I'm going to take the x value that I see, which is clearly -4 here, and I'm going to add 7 to it. And the y value of 6, what I'm going to do is I'm going to subtract 4 from it. So my new point if I add 7 to negative 4, or if I want to just count, because you're going to have graph paper, you're going to have graphs on the interim for sure, I'm just going to count 7 to the right. So 1, 2, 3, 4, 5, 6, 7. And that's going to put me at the x value of 3. Okay, so algebraically, if I have negative 4 and I add 7 to it, I'm getting 3. Then my y value of 6, well, I'm going to subtract 4, and subtract means down. So if I was over here at 3, I'm going to go down 4. 1, 2, 3, 4. So that's going to give me my new point of 2. So basically, this method here, this middle line, is me translating this point of negative 4, 6 over to the new point, which is going to be 3, 2. Okay. Rotations, good question. So let's go with some rotations here. So with rotations, I'm going to keep this same point of negative 4, 6. So what you are probably going to see, okay, is not so much the rules, because the rules will be provided to you, but maybe more so of the quadrants. So remember that this quadrant in the upper right-hand corner is my quadrant 1. The quadrant to the top left is 2. The bottom left is 3. And the bottom right is 4. Now, what I might ask you is, or what the interim might ask you is, if you just have a starting point at negative 4, 6, and you want to rotate it 90 degrees counterclockwise, which quadrant will it end up in? Well, remember that counterclockwise is very, very well named. It's counterclockwise. So it's going around towards the left. So if it starts at negative 4, 6, that point's going to be somewhere in quadrant 3 with a 90-degree counterclockwise turn. Now, if I said let's take this point, negative 4, 6, and let's rotate it 180 degrees counterclockwise or clockwise, because 180 degrees is the same either way, okay? Because it's 2 quadrants that I'm moving regardless of the direction. So if I said 180 degrees clockwise, 1 would be 90-degree turn, and then a 180-degree turn will be 2 quadrants down. So 1 to the right and 1 down. So my new quadrant is going to be here in quadrant 4. Counterclockwise of 180 degrees is 1, 2 again. Because remember, each quadrant is 90 degrees. So 90, 180. So it will be in quadrant 4 again. Now if I said negative 4, 6, and I want to go a 270-degree counterclockwise turn, that means we're going to count 3 different ways, 3 quadrants. So counterclockwise again, 90. Hopefully you can see the mouse pretty well. 180, 270. So negative 4, 6 will end up in this quadrant. If I want 270 clockwise, 90. Because remember, clockwise is just like a clock, like you've been reading that clock your whole life. 90, 180, 270. So it'll end up in quadrant 1, 2, 3. All right, so hopefully that helps out just a little bit. Triangles and angles. Okay, good question. So let's see how I can do that. So know that there's always 3 angles in a triangle, right? And that's obvious because tri means 3, right? Like tricycle, triangle. And those 3 angles of that triangle have to add up to 180 degrees. They have to, okay? So if I give you 1 or 2 of those angles, you should be able to find out the 3rd angle. I'm going to try. Oh, no. Actually, sorry, it won't work for me. Let's see. How can I work this out? Bear with me. Let me try to get a PowerPoint going here. That might work a little bit. How many people? 10 viewers. Oh, yeah. Okay. Come on, PowerPoint. You're taking forever. Just regular. Go away. Go away. And go away. Okay. So you need to get this. All right. Hopefully you can see that. Can you see that? Yeah, you can see that a little bit. Okay. So I'm going to put a triangle in here. Okay, here's my right triangle. Okay, so you can't see that as well as I want you to. You're not working. You should be working better than that. No, you should be working. Why aren't you working? It's not good. Let's see here. Not terribly certain. How come you can't see that? Oh, it's crazy. Can you see that now? I think you can see this. Let me know if you can see this triangle that I'm moving around, because PowerPoint works a little bit differently with this program. So if I have a right triangle and I have, let's say that I have a line coming out from this side. Hopefully you can see that line. Okay, so let's say that I give you this angle here, which is an obtuse angle. Let's say it's 130 degrees. Okay, so again, let me know if you can see this, so I'm not freaking out about this here. No, I'm already didn't find the calculator. Apologize. Okay, thanks, cool. So let me get back to that. So okay, so let's say that this obtuse angle is 130 degrees, right? Now, let's just make sure we understand each other. If I want to find this angle, x, okay, this acute angle, and I know that this obtuse angle is 130, well, this is a straight line. Now, forget about this 90-degree angle for a second, because I realize that that's still part of this line, but it doesn't matter. I just want to focus on the line that contains both of these points, or both of these angles. So you know that a straight line has to equal 180 degrees. So if one part is 130, I am subtracting 180 from 130, and I'm going to get 50. So x, this small angle, this acute angle in here, is going to be 50 degrees. Okay, so I just want to make sure we understand each other there, okay, before we move on. So both things equal 180. A straight line equals 180, so any angle that's on that line equals to 180 when you add it together. And the three angles of a triangle are also 180 degrees. So let's say that, yeah, you know what, let's go back and put this as 50. What's this angle? What's the measure of that angle? Okay, so remember, this is a right triangle, and I know it doesn't have the little box here, but I'm telling you it's a right triangle. How can you figure out what this angle measurement is? Well, I know that all three angles of a triangle equal 180, and I know that this is 50. Well, if this angle here that I'm circling with my cursor is 50, this is 90. So I know two of the three. And in math, whenever you have all of the data or all of the numbers except one, you're able to solve for the missing piece. So 50 plus 90 is 140. And if I know that the three angles are 180 degrees, 180 minus 140 means that this angle is 40 degrees. Okay, so that's kind of how I figure out problems that look like this a little bit. All right, so let's make a triangle that's not so right. Like, it can't be wrong. Okay, that was lame. So let's say that this is now, let's do a different problem, because that was easy because it was a right triangle. But let's go ahead and say that this here is 115 degrees. Now let's make it easier. Let's go 110, not 11-0. Thank you. So that's 110 degrees. This is 30 degrees. So what's this going to be? So take a minute, take a look at that if you can see it. Take a look and see what you think. So there's certainly some things going on with this, right? We want to make sure that we want to make sure that you understand the whole thing here very easily, right? So here's what we do. Wah! I think you're on a delay because I'm watching my YouTube and it's a delay. It's bizarre. It's very strange. I don't know how much of a delay it actually is. It might be a full minute. Maybe it's 2 minutes. It's bizarre. It's really sunny outside. The dog stopped barking too, so that's a little bit weird. Okay, so anyway, so let's go for this whole process now. So let's see. Oh my gosh, no. Okay, let's go back to this. I got 110 degrees here, which is my obtuse exterior angle. So don't get it confused with alternate exterior. There's no parallel lines here. But this is an exterior angle because exterior just simply means outside. So this is the outside angle of this triangle, and the inside here is 30, and I'm trying to find x. But you know something else that's extremely important in this information here. You know what this angle is that I'm about to put this little box around. Because, again, this is a straight line of 180 degrees. So I know that this is 110 degrees on the outside, and a straight line has to equal to 180. So I know 180 minus 110 is 70. So that means that this angle inside is 70 degrees. So now I have all the information I need to solve for x. 30 plus 70 plus x needs to equal to 180 degrees. So 30 plus 70 is 100, and 180 minus 100 is 80. So that's going to be the missing piece to this triangle. Okay? So that's how I solve these types of problems when I have an exterior angle. Don't always just simply add the exterior angle and one of the interior angles together to get the missing. That's not always going to work. So you always want to try to do things mathematically that will work for you 100% of the time. So don't rely on a gimmick so much as, oh, I can just add those or I can just subtract those. Just make sure. You know a straight line is 180. So just go ahead and find the missing pieces and go ahead and solve for it. Okay? Hopefully, Allie, that answered your question. So what else do we got going on here? What else do we have? Let's talk about a couple of exponent problems. Okay, because we got about 20-ish minutes left. Let's go ahead and do a couple of exponent problems. Translations. Okay, Omar, I'll do a translation problem in a second. Okay, so actually, I might be able to do that right now. Hold on. I don't want to leave you hanging here. So, Omar, you missed this one before maybe, but I want to make sure you get this now. So, oh, it's so weird. I don't know why it does that. Okay. I'm going to get rid of this. Let's go here. Okay. So, Omar. So, and pretty much anybody who wants. Let's do another problem here. Let's go -8, -3 or 4. Okay, so I have the point -8 comma -3 here. So I want to go ahead and translate this point. Let's just do an easy one first, and then we'll go back to another one in a second. So let's go 10 to the right and 4 up. Okay, so I want to write that again. So let's go 10 right and 4 up. Okay, so that's the easy way to do the translation, because translation, if you remember, they're just simply directions. Okay, so I'm going to go 10 to the right and 4 up from this point. So I'm going to count 1, 2, 3, 4. Let me back up. You only count 1 when you move one box. Okay, because some of us are counting 1 before we move, and this is like 1, 2. That is not correct at all. We want to make sure that we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, which is going to give us the x value of 2. And then from this point, I go 4 up. 1, 2, 3, 4. My new point should be 2, 1. Okay. Now let's think about this for a second. I went 10 to the right. Right or left is an x value. That's something that approaches x here. Okay. So I'm going to go plus 10. So -8 plus 10 is 2. So I know I'm right with that point. And then -3 is a y value. And up or down are also y values. So from -3 plus 4, because up is plus, I'm going to get the positive 1. So again, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Okay. Now the other way that you're going to see this is with the x and the y thing. So let's do another one. But we'll use the same values here. So let's say I wanted to go x minus 3, comma, y plus 4. I don't want to do the same one. 7. Now, this is another way you're going to see this translation. Remember that x represents left or right, and y represents up or down. So I can very easily here go -8, which is x, -8 minus 3. And -8 minus 3 is -11. And you can do that mathematically, or you can actually use the graph for that process. -3 is a y value here that I'm circling, plus 7. So -3 plus 7 is positive 4. And that gives me my new point. Now let's actually use this and count from red, because red was what we started with. So I'm going to go 1, 2, 3, because negative means left on x, and y plus means up. So 1, 2, 3, 4, 5, 6, and 7. So blue is my new point for sure. Okay, so you could do this thing here that I'm highlighting. You could go what we like to call algebraically, meaning just plug in the -8 for the x and the -3 for the y, and then we can add them together to get -11, 4. Or you can just simply count 3 to the left and 7 up. Okay, not sprite, because you can't go up sprite. That doesn't make any sense. All right, where are we at? Where are you guys at? How can I help you? Oh, it did that again. I'm definitely going to fix that for tomorrow, no doubt about it. I said we would do some exponents, so I want to make sure I get at least 1 or 2 exponent problems in here, but I have to do it into PowerPoint. So let's go ahead and do a couple here. So let's say we want to do multiplication. So let's make it a little more challenging. Let's go. Oh boy. All right, let's go 4x on the inside and 3 on the outside. Okay. I know you can't see that really well, so I'm going to make it a little bit bigger. I think I'm going to make it a little bit bigger. Okay. Hopefully you can see that. So here I've got 4x inside the parentheses and a 3 on the outside. Yes, I can do division exponent ones too. I'll do the multiplication ones first because they're a little bit easier. So when there is parentheses in anything in math, any single thing in math at all, I'm going to go ahead and distribute the thing on the outside of the parentheses to the thing on the inside of the parentheses, right? So this is 4 to the third power. Now, it's not 4 times 3. It's 4 to the third power, meaning 4 times 4 times 4. So 4 times 4 is 16, and 16 times 4 is 64. Okay, so I'm going to have this equal to, oh, I have to make this again here. That's poopy. Whoa, type equation. Can you get any bigger? So it's going to equal 64. Okay. I'm also distributing the 3 to the x. Remember, if there's never a 1 in front of a number or a letter or a 1 as an exponent, it says 1. Okay, so I am multiplying the exponent to the exponent. And again, there's not a 1 here, but there should be. X to the first times 3 is x to the third. My final answer to 4x to the third power is 64x to the third power. Okay? That's how we do these types of problems. Now let's make another one that's kind of a little bit more challenging, right? So let's say that I had, I kind of want to keep this, but it might not work out so well. Let's go with, let's go negative 2xy to the fourth power. So what do I do here? Again, I see parentheses. Okay. What I need to do is I need to distribute the 4 to every single thing inside here individually. This says, or this is going to say, negative 2 raised to the fourth power, because the 4 is going to simply distribute to the negative 2. In your calculator, you're going to do, because you're going to have calculators on the interim, you're going to do negative 2 to the fourth power. So negative 2 to the fourth power has to give you a positive answer because it is an even exponent. And what that's going to mean is I have to make sure that the negative disappears. So that's going to be negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is 4. And then another negative 2 times a negative 2 is another 4. So my negative 2 is going to end up turning into a 16. Okay, so 16 is going to be part of my answer. It's going to be the number value of my answer. Now, this x and this y are two completely different things. The 4 outside, the 4 exponent, is going to distribute to both of them individually. So I'm going to have here x to the fourth, and I'm going to have a y to the fourth. I cannot just simply put the 4 on the outside of this xy. They are individual because I cannot combine them. So my final answer here is going to be 16x to the fourth, y to the fourth. Okay, so hopefully that answers your question a little bit more regarding the division or the multiplication problems. Okay, let's go ahead and do a division problem. Or 2. Or 100. No, if my other program was working, we'd be able to do a lot faster. But because I have to type this in, which is super lame, we're just going to have to work it out. So, division. Oh, division. Let's go a little smaller. That's going to be a little annoying. Okay. Oh, what kind of a problem should we make for you? Let's go 30. X6. And I definitely want to make this as hard as I possibly can. Y10. Divided by... let's go 5. X3. Y. Let's get rid of this. All right, here's my division problem. So 30x to the 6th y to the 10th divided by 5x to the 3rd y. So as we did multiplication, the rule was to, well, add the exponents, but there was parentheses, so we have to multiply the exponents. But multiplying and adding are linked. Now we're doing division, so division and subtraction are linked. Now, there is important pieces to remember here. The coefficients, the 30 and the 5, they must be divided straight out. We don't subtract because they are coefficients. They are not part of this XY nonsense that is going on over here. So 30 divided by 5 is 6. I don't want to use that 6. I want to use a regular 6. No, go away. Terrified. Okay. 6. That's 5. Okay. I'm dividing 30 by 5 to get a 6. How about an equal sign? Okay. Thank you. Okay. Now that I'm going over to the exponents with the base of x and a base of y here, now this is the part that I am going to subtract. X to the 6th divided by x to the 3rd means 6 minus 3. And that is 3. So my exponent is going to be x to the 3rd. Whenever I can get that to work. Now, y to the 10th divided by y. Now, again, don't get fooled. That's y to the 1st. So y to the 10th divided by y to the 1st is 10 minus 1, which is going to give me y to the 9th power. So be really careful when you don't see a specific number over a variable, because it still means that there's 1 there. So my final answer is 6x to the 3rd y to the 9th power. Okay? So that's how we work that process out. Nia, I see you, but I'm going to have to wait on that. I will do a tax problem tomorrow, and I will also make sure that I send it to you if you're not able to log in tomorrow. So I apologize for that, okay? So I promise you I will do that. I'm actually going to write that down right now so I can go ahead and remember that. Piece of paper. You don't want to pay tax. No one does. Tax sucks. All right, tax problems. I want to write that down so I don't forget for tomorrow. Again, if you're not able to log in tomorrow, I don't know really what time I'm going to do it. I will promise you that I send it to you or give it to you as an additional video so you can work that out, okay? You're very welcome, Nia. Thank you. All right, so that's my division problem. Let's go just one more step in the challenging way. So hopefully you understood that, Allie. Did that help? So let's go ahead and erase this nonsense. Let's do another problem. So let's go ahead and do 6x to the 3rd, y to the 2nd, divided by 2x to the negative 3rd, y. I do want to make another variable here. Let's go y to the negative 4th. Sorry to hear that, Omar. No worries. I'm going to do this again tomorrow. I'll let you know. Probably sometime in the afternoon, okay? So we can work that out for tomorrow. All right, thanks for being on today. So 6x to the 3rd, y to the 2nd, divided by 2x to the negative 3rd, y to the negative 4th. So again, this is a division problem, so I'm going to be subtracting the exponents, but there is a little bit of a trick here because the denominator exponents are both negatives. But we're still making sure that we subtract the exponents. But I've got a 6... and I've got a 2. I can do that, sir. 6 divided by 2 is 3. Okay? So that's very simple. I have to divide the numbers in front. Okay? So x to the 3rd divided by x to the negative 3rd. So this is going to actually be 3 minus negative 3. And yes, I said that correctly. I'm going to have 2 minus signs in a row, which means I'm going to make it one big plus. So 3 plus 3 is 6. Now, here's the key. Because the result of this exponent nonsense is a positive, it is going to stay as an answer in the numerator. Positive answers stay in the numerator. Negative answers go in the denominator, and I'll explain that in a second. Actually, I'll explain it right now. Y to the second divided by y to the negative fourth. I'm subtracting these things. So it's 2 minus negative 4. So 2 minus a negative 4 is another 6, positive style. So it's going to be a y to the 6th power. But what would have happened if there was a negative 2 here? Oh, no, that would not have helped. What if there was a 4 there? Now that makes things scary. 2 minus 4 is negative 2. That is where I'm going to put y squared in the denominator. And I'm going to erase this stuff in a second because this doesn't work out how I want it to. So 3x to the 6 is the numerator part because the result of 3 plus 3, or 3 minus a negative 3, is 6. But 2 minus 4 is negative 2. But because negative 2 is my result, y squared is going in the bottom. Okay? Whenever you get the result that's negative of doing these exponent type problems, you're going to put the result in the denominator but make it positive. My final answer is 3x to the 6th over y squared. Okay? So hopefully that helps you out a little bit there. Okay? I have enough time to do maybe one more problem if you'd like. But again, no worries. I'll be on tomorrow as well, but I need to figure a couple things out with my Doceri iPad app, so it's a little bit easier to get these problems done. Okay? So what kinds of questions, or what question can I answer in the last couple of minutes here for you? Let's see how many people I got on. I got about 12 people on. That's good. 12? Oh, no. 3. Where did that 12 come from? That's bizarre. That's super bizarre. Oh my gosh. No. Okay. Yeah, that's totally fine. So come during homeroom, and we can work that out as well. Okay? No doubt. All right, guys. So if you are good to go, you can certainly still, ask questions on Remind. I can give you those questions if you need to. But let me know how I can help you. Hopefully this helped. Thanks so much for signing on today. Today was good. I got a pretty good turnout from the kids. I think I got about 10 kids or 12 kids from the algebra group. And, I got up to about, 6, 7, or 8 of you here. So that's good. First time is tough because we weren't able to work out exactly what we wanted to. Like right now, you're seeing things that are just ridiculous because it's just like 48 fields open. We'll work that process out as we get further along in the process. So I appreciate you. All right. So I'm about to sign off because I don't see any other questions. Guys, thanks so much for being on. And I will text you tomorrow when we are good to go. I'll give you at least a couple of hours notice. All right. See ya.